Hey everybody, this video lesson is going to cover the introductory notes for Unit 4 of Stoichiometry. These notes are brought to you by Beaker and Honeydew. Let's start our conversation talking about these two conversion factors, Avogadro's number and molar mass. Avogadro's number is used when you're ever converting from moles to atoms or molecules. Molar mass is used whenever you're converting from moles to mass. These two conversion factors are your two most important conversion factors along with mole ratio in order to do basic stoichiometry. What is Avogadro's number? Well, it's a number that represents the total number of atoms or molecules in 1 mole of a substance. Remember that 1 mole is a unit of quantity that we use in chemistry. You can have a mole of anything. You can have a mole of cars, a mole of dogs, a mole of cats, a mole of human beings, but it's only practical to count moles when you're discussing very small objects like atoms or molecules. Now, Avogadro's number here is out to 4 digits. You've often seen it as 6.02, sometimes referred to as 6.022 times 10 to the 23rd of any object. The molar mass is the mass in grams of 1 mole of a substance, and that number is different depending on the substance. You can have a mole of an atom or a mole of molecules, but you simply add together the masses from the periodic table. Now, you did this so often last year that this is probably just second nature to you. But for example, if you had something like sulfur, you just simply find its molar mass on the periodic table, which is about 32. That is the average atomic mass of one atom. In AMU, it also is the mass of 1 mole of sulfur. Now, you can do it also for molecules like H2O. Simply add together H plus O, and you get the molar mass. In this case, water is about 18.01 because each H is 1.01 and O is about 16. If that's the case, it would be about 18.02. Let's take a look at this first example. It is a calculation that involves both molar mass and Avogadro's number. It reads, calculate the number of copper atoms in 63.5 grams of copper. Before I even begin this process, I'm thinking to myself, I have grams. I've got to convert to moles. Moles is the ultimate converter, which means that you can convert to moles and you can convert out of moles in almost all circumstances involving stoichiometry. And so if you can get to moles, you can get out of moles. My first move is to go from grams to moles. And then I can move from moles to atoms. So to go from grams to moles, I use molar mass, and to go from moles to atoms, I use Avogadro's number. I just need to set up the work, calculate, and round to the right number of significant figures. So I set up the problem like this. I first start with the number I'm given, and I divide by the molar mass by setting up grams on the bottom, moles on the top. The molar mass of copper is 63.55. Then I multiply by molar mass, Avogadro's number, and I get 6.022 times 10 to the 23rd atoms of Cu. Then I multiply by 6.022 times 10 to the 23rd atoms of Cu, and I cancel out my units, and I get 6.022 times 10 to the 23rd atoms of Cu. This should make sense to you because if I take the mass of copper given and divide by the molar mass, which happens to be the same number, I get 1. And 1 times 6.022 times 10 to the 23rd is 6.022 times 10 to the 23rd. But this is how I would set up the problem. A very simple problem, but this is how I'd set it up. Now, some people like to set it up with parentheses around each number. That's fine. Some people like to set it up with multiplication signs between each number. That's fine too. Everybody does their stoichiometry a little bit different. I refer to this as the railroad tracks. But that's what I would do. You can do what I do, or you can do whatever you do as long as it looks good. Now let's rank the 3 that you see in order from greatest number of atoms to least number of atoms. We need to convert each one of these to moles using their molar mass. For this first one, I take 107.9 grams of silver and divide by its molar mass, which is 107.9. So that's going to equal 1 mole. Next, I'm going to take these grams of zinc and figure out how many moles those are. 70 divided by its molar mass is 65.38, gives you just roughly greater than 1 mole. And finally, 21 grams of magnesium multiplied by its molar mass is equal to slightly less than 1 mole. So if I'm going to put these in order from greatest to least, I'm going to put B first, then A, and then C.